In this module, we will cover concepts of aggregating dimensions and measures. Alright, let's begin by learning what different types of aggregations are available in Tableau. Before we jump into the types of aggregations, let's first understand what aggregate functions even mean. Aggregate functions allow you to change the grain of the data or helps you summarize the data. Let's talk about what aggregation means now. The mathematical functions that produce aggregated data are called aggregation functions. Aggregations allow you to perform calculations on a set of values that return a single value. In other words, aggregate functions allow you to summarize or change the granularity of your data. The type of aggregation applied varies depending on the context of the view. In Tableau, you can aggregate dimensions or measures. It is more common to aggregate measures. Dimensions are qualitative and do not total a sum. For example, columns like customer name, segment, or ship mode can be described as dimensions, whereas measures are numerical fields that mathematical functions work on. While it is more common to aggregate measures, you can aggregate dimensions in Tableau. Some of the most common aggregate functions for dimensions are min, max, count, and count distinct. And for measures, there are various aggregation options. Some of the most common aggregate functions are sum, average, min, max, median, count, and count distinct. Statistical functions like correlation, covariance, population covariance, percentile, and standard deviation are also supported in Tableau. You may check Tableau's knowledge base to learn which data sources are supported when working with statistical functions. It is also important to note that you can aggregate fields in Tableau using table calculations like running calculations, ranks, and window calculations. So these are a few different types of aggregations that you can use in Tableau. We will take a look at a few examples in a future demo. Here is an example of the syntax that you can use in Tableau. Customer name as a dimension can be wrapped in a count distinct to get an aggregated number of customers. Profit as a measure can be wrapped in aggregations like sum. Statistical functions like correlation returns the Pearson correlation coefficient of two expressions, and hence these expressions can be used with a comma delimiter wrapped in a CORR function. And finally, since table calculations returns the sum of the expression within the window, you can use a measure like profit and wrap it in a window sum, for example, with a start and an end offset. Right, in this clip, let's learn what granularity and level of detail means. To characterize the scale or level of detail in a set of data is called granularity. The greater the granularity, the deeper the level of detail. An easy way to look at granularity or level of detail would be to ask yourself a question. What makes one row of data? Is it one row per user per month? Or is it one row per month? If you understand this concept, you will have an easier time understanding how aggregations are performed. Here is an example. In every Tableau worksheet, there are columns and rows, and pages and filter shelves. There is also a marks card, which is a key element to understand when working with granularity. As you drag and drop fields to different properties on the marks card, you impact the view even if those fields are not present in the actual view. Let's see what this actually means. Here I have dragged customer name on the detail shelf. And as you see, Tableau draws one mark for every customer in my data indicated by the pink squares in my view. So in this example, one row is equal to one customer. Whereas in this example, I changed the aggregation on the detail shelf to count distinct of customer name, and in which case I get an aggregated value of the count of customers. So in this case, one row equals count distinct of all customers. Here is another example of how fields on detail shelf can impact the results even if they don't really exist on the view. In this example, I'm showing sales by year of order date. I, however, see that my bar chart shows slices of categories in each year. Even though your intention might have been to show overall sales by year, you see category level of data because that field is included on the detail shelf. So be mindful that placing fields on the marks card can impact the view. Let's now talk about row level calculations. Row level calculations are basically raw fields in the data, expressions that allow you to transform values or members at the data source level of detail are called row level calculations. In this example, the results of this calculation will be output in every row of my data. Note that Tableau will use the default aggregation method used for profit and sales and automatically aggregate the value in the view based on that default selection. On the other hand, in this example, I am using the same pills for profit and sales, but aggregating them by using the syntax sum. In this example, the dimensionality of the expressions is view level. Let's bring both of these calculations on the view. In this example, Tableau looks at every row in the data for each year and outputs a profit ratio at row level. In the aggregated view by year, Tableau then sums those row level percent values. As you can see in this example, the percent for 2021 looks like a large number because Tableau added the row level percentages. On the other hand, if I wrap my profit and sales fields in a sum, this means that the dimensionality of the expressions is at view level, meaning in the 2021 example, Tableau will take the aggregated profit value of $51,684 and divide that by the aggregated sales value of $494,040, resulting in a profit ratio of 10.46%. Adding more dimensions to the same view will then break down the view level calculation accurately because Tableau looks at what fields are in the view and then outputs the result from the aggregation. Also important to note that row level calculations are aggregated by Tableau when you bring the calculations to the view. In this case, since we did not aggregate values in the calculation, Tableau aggregated it to show a sum. Whereas if you remember in the view level calculation, we wrapped our sales and profit fields in a sum syntax within the calculated field window. So there was a predefined aggregation in our calculation. Tableau encloses the calculation in an agg function, indicating the calculation is aggregated. Clip, let's learn about how Tableau aggregates dimensions and measures. You can aggregate a dimension in your Tableau workbooks as minimum, maximum, count, or count distinct. When you aggregate a dimension, you create a new temporary measure column, so the dimension actually takes on the characteristics of a measure. In this example, I am interested in a count distinct of my customer name columns in my dataset, so I am choosing a count distinct aggregation by right-clicking on the pill and selecting count distinct. Apart from min, max, count, and count distinct, you can also use the attr function to return a value of the given expression if it only has a single value for rows in the group. Otherwise, it displays an asterisk. Null values are ignored. Attr is the most suitable for when you run into a situation where Tableau yells at you by saying you cannot mix aggregate and non-aggregate comparisons or results in an if expression. In this example, the category field is a non-aggregate field because it is not wrapped in an agg function, in which case you can wrap this field in attr to justify Tableau's if syntax requirements. When you add a measure to the view, Tableau automatically aggregates its values. Sum, average, and median are common aggregations. In this example, the current aggregation is indicated by the green pill. For example, if measure sales becomes sum of sales, you can change the aggregation for a measure in the view from its context menu by right-clicking on the pill. It is important to note that you can aggregate measures using Tableau only for relational data sources. Multi-dimensional data sources contain data that is already aggregated. In Tableau, multi-dimensional data sources are supported only in Windows. You can change the default aggregation of a measure by navigating to the default properties of a field and changing the aggregation method. Depending on your default selection, Tableau will automatically wrap the measure in your chosen aggregation method. Another way to predetermine an aggregation method is to option drag a field on the view rather than simply dragging the field on the view. This is because when you option drag, Tableau shows a pop-up menu in which you can choose how you want Tableau to aggregate. This is also especially useful when choosing a date field and how you group your results in Tableau, since there are so many ways you can bring in a date field to the view. Speaking of aggregating, you can aggregate fields in Tableau at a level other than view level of detail. In this example, my view level of detail is at year of order date and category. However, my annual sales field shows sales at the level of year of order date and ignores the category level of detail. While you can aggregate the fields using LOD expressions, it is important to note that the results of these calculations are row level. If you notice, the total sales values are repeated for every category in the same year. This makes it easy to compare sales by category to total sales in the same year. Also, note that it is not required to use any keywords in the fixed level of detail expressions. In this example, if you remove the order date dimension, the calculation will be performed against the entire dataset without regard to the year of order date. You can also aggregate dimensions and measures using table calculations. In this example, we're showing total sales. If you simply place the calculation on the view, you will notice the results by year do not match the previous screenshot. And this is because table calculations need to be computed using a specific partitioning. In this example, you can see that the calculation is being performed at table level, meaning without regard to year or category. Tableau simply summed the results of the entire table in the view. You can, however, change the partition to pane down if you wish to calculate sales by year. In the next clip, we will go through examples of aggregating dimensions and measures. In this demo, let's take a look at how you can aggregate dimensions and measures. If you are familiar with SQL, Tableau is essentially executing these queries in the background as you drag and drop fields on your view. The leftmost field on the row shelf is how Tableau groups fields. Alright, here we are in Tableau Desktop, and I have opened the starter workbook from the course materials. Let's look at dimensions first. In this example, if I want to know how many distinct orders were made in each of these regions, one way to look at that is to drag order ID field on the row shelf. If I then click on the central region to select the marks, I see that we have 1,179 orders that were made in the central region. Similar to the granularity example I showed earlier though, in this case, we only want to see one row for each region with an aggregated value of the order ID field. To do this, let's click on the order ID field and choose Measure and select Count Distinct. When I do that, you will notice, based on the type of data we're showing in the view, Tableau automatically creates bar charts. If I then drag the Count Distinct of order ID field to Labels on the marks card, you will notice that we now have one row per region with aggregated order ID values. If I remove the order ID field from the marks card, you can also write an ad hoc calculation by double-clicking on the marks card. You can then write the same Count Distinct order ID as I'm doing here, and then drag it to text to revert back to our original view. Here is another example of aggregating dimensions. Min and max are most common aggregation methods when it comes to using dates. Because you might have questions like what was the first order date in the central region to calculate metrics like customer tenure, for example. In this case, as I mentioned earlier, you can option drag order date field to drop it on the text shelf in the marks card and select min from the list of available options. We now have only one row per region showing the first time an order was made in a particular region. You can also write a calculation like, let's say, max of order date. If you then bring this field on the view, you will notice the agg function on the max date, but a min function on the min date field because you chose the aggregation from the drop field versus predefining a calculation for max date. Let's clear the view and look at another example. Let's say you drag category to the column shelf and drag sum of sales on the row shelf. And let's say you only want to label the bar where the category is furniture. You can write a calculation like this, where you're asking Tableau to output the sales value where category equals to furniture. However, if you notice, we see an error, which indicates that we cannot mix aggregate and non-aggregate comparisons in an if statement. Here, if you wrap the category field in an attr function, it'll help resolve that error. Let's click Apply and OK, and drag the results to the label shelf. If you now see, we have a label for the bar only where category is furniture. attr is also the default dimension aggregation when you use data blending. Data blending is a method for combining data from multiple sources. We covered this concept briefly in the first course in this path. Data blending brings in additional information from a secondary data source and displays it with data from the primary data source directly in the view. If I right-click on this data source and duplicate it, for example, and then go back to my primary data source and create a new field using the customer name from the duplicated data source, you will notice it automatically comes in as an aggregated field. This means that if I use any other field from the primary data source, those fields will also need to be aggregated. Alright, let's close this calculation and close the duplicated data source, since this source was created for demonstration purposes only. So that is how you can aggregate dimensions using aggregate functions like min, max, count distinct, and attr in Tableau. Alright, let's now look at aggregating measures. It is a similar idea like aggregating dimensions, where you bring in the fields and Tableau performs a query in the background to give you the results based on the fields in the view. In this view, if I have a region on the row shelf and if I double-click on sales field, you will notice sum of sales for each region. Similarly, if I drag category, you will see sales field breaks down further by the category field. You can keep adding and removing fields, and Tableau will adjust the view based on the view level of detail. If you are familiar with SQL, Tableau is essentially executing these queries in the background as you drag and drop fields on your view. The leftmost field on the row shelf is how Tableau groups the fields. You can also change the aggregation from the Fields drop-down menu right on the Marks card. If I change the aggregation to average, Tableau now performs an average calculation based on the fields in the view. Similar to the attr example I showed earlier, if you have a calculated field that aggregates a dimension, you will need to make sure other fields in that calculation are also aggregated. In this example, because the category field is an aggregate and wrapped in an attr function, my sales field needs some sort of aggregation, like sum or average or something else. If you open a new calculated field, you can open the syntax menu to see available aggregate functions. To provide statistical significance to the dataset, it becomes important to measure the standard deviation of a set of data values. To measure sample standard deviation, you can simply wrap your disaggregated data column in stdev syntax. Here I'm wrapping my sales column to measure standard deviation. This will help quantify the amount of variation in my dataset. Similarly, wrapping my sales column in a median syntax returns a median of a single expression. Median can be used with numeric fields only, and no values are ignored in the calculation. So that is how you can aggregate measures in Tableau using common aggregate functions. Demo, you will learn level of detail expressions and table calculations. People often find it difficult to decide whether they should use a table calculation or a level of detail calculation like fixed, include, or exclude. Tableau's diagram helps you choose the right type of calculation based on your need. It goes something like this. If you already have all of the data values you need on a visualization, and if the layout of your viz permits use of table calculations, like rank, running sum, or window sum, use table calculations. If you don't already have the data values you need on a visualization, depending on whether the grain of the question being asked matches with the grain of the data source or grain of the viz, you could go in two directions. If the grain of the question does not match the grain of the viz or the data source, you will need to use a level of detail calculation. Because level of detail calculation supports calculation at a level of detail other than view level. And if your grain does match the grain of the question, you can simply use a basic expression like average sales, for example. Alright, let's now take a look at an example. Here I am in Tableau Desktop. This view shows a single customer and their row level detail of products they purchased and their sale amount. If I highlight the customer and view their summary and data source level data, you will notice we see these many rows, both in the summary and the overall rows in the entire dataset. So this means we're looking at row level detail for this particular customer. If you then want to see and compare how their sales compare total sales, you can write a level of detail expression like this, where I am asking Tableau to return total sales value for this customer at an order ID level. If I then bring in the field to my view, you will notice that we now see the total sale value for each order. If you also notice, this number is repeated on every row because it's easier for us to compare sales value by product to the total sales value by order. You can then reference these fields in a new calculation like so to perform a percent of total calculation. But I am simply using my raw sales field and the new customer sales field to show me percent of total. If you then bring in the field to the view, you will notice a new column created. Note that you can change the default number formats of a field via the Fields drop-down menu. If I remove customer sales in the same example, you can leverage table calculations to do the same exact thing we just did, where you can duplicate the sales field to perform a percent of total calculation using quick table calculations. However, if you notice, the percents don't match what we saw earlier when we used a fixed expression. And this is because when you use table calculations, you will want to ensure you're partitioning the fields accurately. If I right-click on the table calculation and choose Edit Table Calculation, you will notice that Tableau highlights the entire table in the view, as opposed to highlighting and calculating percent of total for each order ID in my view. You can change that by choosing Pane Down, and you will notice that my percents using level of detail expressions and using table calculations now match. You can also drag the calculation you just created on the marks card to the data pane and rename the field if you desire. You can right-click on the field and click Edit to see what Tableau created when you used percent of total quick table calculation. You can then reuse this field in other worksheets within your workbook. Here is another example of table calculations. Let's say you have a view with category and subcategory and their sales. If you then create a percent of total calculation on the sales field, you can choose how you want Tableau to compute the percent by using the Compute Using option. Let's say you choose to compute using a specific dimension rather than table or pane, and choose subcategory. If you then attempt to remove the subcategory field, you will get an error message saying Tableau requires a field that is missing from the view. This indicates that in order to perform a table calculation, you need all the fields in the view, which contradicts the level of detail expressions, wherein level of detail expressions support calculations at level of detail other than the view level. So you can predefine the level of detail in LOD expressions and use it elsewhere on the workbook, regardless of what the view level detail is. Alright, let's now take a look at an exclude level of detail expression. Since level of detail expression supports calculations at a level other than view level of detail, in this example, let's say you have a yearly breakdown of sales that are colored by the category dimension. If I hover over the bar sections on 2021, you see a distribution of sales across category for values like technology, office supplies, and furniture. To add more context to this view, you may want to have a field that indicates total sales by the year. So it's easy to see, for example, that this is the percentage of what number made up sales for technology. If you drag the sales field to rows and convert it to measure, you will notice that we lost our stacked bar chart, and Tableau draws 3 marks for each of my category values, instead of a single annual number for 2021. Let's hit undo and revert back. You can instead write a calculation that excludes the category level of detail and shows you sum of sales by year. If you then drag this calculation to rows and convert it to a discrete value, you will see we have our bar chart preserved with stacks by category. And yet our total sales value shows sales by year. This is an example of how you can use level of detail expressions using specified levels rather than depending on how Tableau will calculate measures based on the fields in the view. This is also an example that shows how we use table calculations and a level of detail expression on the same view. The stacked bars are using a percent of total table calculation, while the discrete sales field on the row shelf is using a level of detail expression. And finally, let's take a look at an example when using table calculations is the only answer. If I want to rank states by their sum of sales and see how each state compares to other states, there is no other way to rank a field except to use table calculations. I can simply do a rank quick table calculation and notice that my states are now ranked by sum of sales. So this is how you can aggregate dimensions and measures in Tableau using level of detail expressions and table calculations. So finally, here are a few quick takeaways. There is no silver bullet when determining what's right to use, table calculations or level of detail expressions, because it always depends. Some data sources may not support level of detail expressions, for example. The layout of the viz matters because table calculations requires fields in the view, whereas level of detail expressions do not. And always remember to check the order of operations when working with level of detail expressions. We covered this concept in a prior course, that order of operations dictates how calculations will be performed in Tableau. And finally, there are always trade-offs, whether it is performance, scalability, simplicity, or flexibility of use. Tableau suggests that a good rule of thumb is that you pick any two. To wrap up this course, Tableau Desktop Specialist Understanding Tableau Concepts, we learned about data field roles and how this concept is foundational to using Tableau. Date parts versus date values, discrete versus continuous filters, different types of aggregations that are supported in Tableau. We also learned about granularity and how that is a single most important concept to grasp to understand how aggregations work in Tableau. We looked at ways you can use to aggregate dimensions and measures. We looked at examples of how level of detail expressions and table calculations can be used in Tableau. And before I let you go, here are a few things to remember. Dimensions contain qualitative values, and measures contain quantitative values. Remember that you are able to change default aggregation methods for dimensions and measures. You cannot mix aggregate and non-aggregate functions in Tableau. They always have to match. If you see a field wrapped in an agg function, it is a sign that the field you're using is an aggregated field. If you don't define scoping keywords in your level of detail expressions, Tableau will aggregate the results across the entire dataset. If you want to go even deeper on the aggregation concepts and calculated fields, check out my other in-depth course using calculated fields in Tableau Desktop. This was the last course in the Tableau Desktop Specialist certification path. I hope that these short courses provided you with the knowledge you need to pass the certification and continue along in your data journey. Be sure to watch the other courses in this path to gain an overall understanding of concepts that you will be tested on to pass the certification. Thank you for watching.